Hello guys, welcome back to the Universe of Tech Hub. In this tutorial, we will learn about Kruskal's algorithm. Kruskal's algorithm. It is one of the minimum spanning tree algorithm. Kruskal's algorithm is a greedy algorithm used to find the minimum spanning tree of a connected weighted graph. A minimum spanning tree is a subset of the edges that connects all the vertices together without any cycles and with the minimum possible total edge weight. And next we move on to the what is Kruskal's algorithm is a greedy algorithm used to find the minimum spanning tree of a connected directed graph. Minimum spanning tree is a subset of the graphs and edges that connects all the vertices together without any cycle and with the minimum possible total edge weight. This is all about Kruskal's algorithm. What is Kruskal's algorithm? And next we move on to the why we need to use Kruskal's algorithm. Kruskal algorithm is particularly useful in network design and where we want to connect various points like computers or cities with the least total cost. It helps in minimizing the cost while ensuring all the points are connected. This is why we need to use the Kruskal's algorithm. It is useful in network design and we want to connect various points like computer cities with the least total cost. So that's the reason we need to use the Kruskal algorithm. Next, we move on to the application. The Kruskal algorithm used in the network design. In network design, used in designing a network such as the telephone, electrical, and computer networks like that. And next one is the transport system. Transportation helps in planning transportation routes to minimize costs. This is the transport system to use. Next, cluster analysis. Used in data mining and clustering to minimize the distance between points like that. And also used in the image processing helps in segmenting images by connecting a pixel with the least weight. So that these are all the applications of Kruskal algorithm. Next we move on to the algorithm, Kruskal algorithm. First step is sort all edges. Begin by sorting all edges in the graph in a non-decreasing order based on their weights. Initialize a forest. A creative forest where each vertex is separate tree. This can be efficiently managed using a union find data structure and also known as disjoint set union DSU. This is the second step, that is initialization step. The first step is sort all edges. Next step is initializes a forest, and next one is process each edge. Iterate through the sorted edge, and for each edge, check if the vertices of the edge belongs to different trees using the union find structures. If they do, add this edge to the minimum spanning tree and unite to two trees. If they belongs to the same tree, skip these edges to avoid the cycles. Next, stop when minimum spanning tree is complete. The algorithm continues until you have added v minus 1 edges to the minimum spanning tree, where v is the number of vertices in the graph. This is all about algorithm. We take one example to how Kruskal's algorithm works. In Kruskal's algorithm, it is used to find the minimum spanning tree for a connected weighted graph. The main target of the algorithm is to find the subset of the edges by using a which we can traverse every vertex of the graphs. This is the main aim of the Kruskal's algorithm. It follows the greedy approach. Next tutorial we will learn what is greedy approach and brute force. What are the problem solving techniques? In this we need to learn Kruskal's algorithm. I take one graph. This is the graph I take. The A to E weight is 5 and E to D weight is 2, A to B weight is 1, A to C weight is 7, A to D weight is 10, C to D weight is 4 and B to C weight is 3. This is the graph, and next I need to take this represent edge, this represent weight. The edge is A to B. The A to B is 1. So next A to C. A to C is 7. The next A to D. The A to D is 10. A to E. A to E is 5. Next one is B to C. The B to C is 3. The next C to D. C to D is 4. Next D to E. D to E is 2. This is the graph edges and weights. Next, we first step is we need to sort the edges based on the weights, right? Need to sort based on this, right? The edges, edge, weight, ascending, sorting, sort A to B. A to B is 1. Which one is small? A to B. Next, which one is D to E, right? D to E weight is 2. Next one is B to C. The B to C weight is The B to C weight is 3. Next, C to D. C to D weight is 4. Next, A to E. A to E weight is 5. Next, A to C. A to C weight is 7. Next, A to D weight is 10. This is now sorted. Now sort the edges given above. Now let's start the constructing the minimum spanning tree. In step 1 is the step 1. First add the edge AB with the weight 1 to the minimum spanning tree. So we need to add the edges, right? A to B weight is 1. This is the first minimum weight. Next add the edge in the step 2. Next step 2, right? So what we need to do is next one is D to E. We need to add D to at the edge D to E or with the weight 2. Next, at the edge, next minimum is in the step 3. What we need to do is we need to add step 3. I need to add B to C. Next one is this E and this is G, right? We need to connect with B to C. This is the third smallest. This is the C. So now no cycle found, right? Add the edge BC with weight 3 to the minimum spanning tree as it is not creating any cycle or loop. So we need step 4. In the step 4, the fourth minimum is CD, right? This is A, this is B, this is C, this is E, and this is D. Next one is C to D. Next we need to connect C to D. This is the Now pick the edge CD with weight 4 to the minimum spanning tree as it is not forming the cycle. As it now forming the cycle. A to B weight is 1 and E to D weight is 2. The third is B to C weight is 3 and C to D weight is 4. Again like this 1, 2. Next, the next step is step 5 is my minimum spanning tree. This is A, this is B, this is E, this is D, this is C, 1, 2, 3, next 4. We need to add the fifth minimum is after the pick, the fifth minimum is AE, A to E. So now we create a cycle. It creates the cycle, including this edge will create the cycle. So we need to discard it. The next step is 6. Pick the edge AC with weight A to C. Right. next edge is A to C. So this form a cycle like A to B, B to C and C to A, again C to A. So we need to discard it. Next 7th minimum is pick the edge AD. A to E, D, right? A to D means it is also form a cycle A to B, B to C and C to D, D to again A. So now we will discard it. Next one is the final minimum spanning tree is obtained from the given weighted graph by using the Kruskal algorithm is this A to B, B to C and C to D and D to E. This is the cost of the MST is the total weight is 10. This is the total. Now the number of edges in the above tree equals the number of vertices minus 1. So the algorithm stop here. This is all about Kruskal's algorithm, how Kruskal's algorithm works. Next we move on to the implementation of Kruskal's algorithm using a Python programming language, self, comma, vertices. These are the parameters. I need to take these are the parameter. Self next self dot v. Self.v equals to self.v equals to vertices. The number of vertices. Next edges equals to empty. List to store all the edges. Next is the encapsulates the graph related data and operates. The self of v holds the number of vertices in the graph. Next, self edges store the edges of the graph as a list of u, v, weight, where u and v are the vertices and connected by the edge with a given weight. Next, adding an edge. Next, I need to define add edge. Add edge. This self, u, v, weight. Self, u, v, weight are the parameters. U, v, the two vertices connected by the edge. U is the starting node, v is the ending node. Weight is the weight of the edge. And the purpose of adds an edge to the graph, it is used to self dot add, self dot edge append u, v, weight. Next, the appends the edges as a list u, v, weight to self dot edge. Next one is find the operation with path compressions. Like we need to define find self, parent, node. Next, if parent node not equal to node. Next, if the parent node is equal to self dot find parent, the parent node. The parent node. Next, path compression. Return the parent node. Return parent node. It determines the root representative of a subset to which a node belongs. Why path compression? It optimizes the find operation by reducing the height of the trees, making the future operation faster. So that is the reason we need to use the define find. Path compression. Next, we need to write define union self, self, comma, parent, comma, rank, comma, u, comma, v. The root u is equals to self dot find parent, comma, u. Next, the root v self dot find. We need to check if rank of root u is less than the rank of root. If it is true, the parent of root u is equals to root v. We need to use elif. Another condition is rank root u is greater than rank root v. Rank root v. It's true. The parent of the root v is the parent of root v is equals to root u. Next, otherwise, else, the parent of root v equals to root u. Root v is equals to root u. Rank root u plus minus plus 1. So this purpose is to merge the two subsets into a single subset. The array that tracks the parent of each subset. The rank is the array that tracks the rank or height of the each subset's trees. UV are the nodes whose subsets are being merged. Next, these are the operations. Compares the ranks to attach the smaller tree under the larger one. If ranks are equal, one tree is arbitrarily chosen and its rank is incremented. Next, we move on to the sorting the edge. Self dot edges is equals to sorted of self dot edges, comma, key is equals to lambda edge. The edge is equals edge of 2. This purpose is to sort the edges in non-decreasing order of weights. Kruskal's algorithm processes the edges in increasing order of weight to ensure the minimum spanning tree is built with the smallest edge weight first. So that is the reason we need to sort. Next, I need to construct the minimum spanning tree. I write the code for minimum spanning tree. That is, we need to initialize empty. It stores the edges including the minimum spanning tree. So that we need to initialize empty. Next, the parent is equals to I for I in range. Self dot v. Rank is equals to 0 into self dot v. MST stores the edges including the minimum spanning tree. The parent tracks the parent of each vertex for find and union operation. The rank tracks the rank of each tree, means height of the each tree. Next one is initialization. Each vertex is its own parent initially. The parent of I is equals to I. The rank are all set to 0. Next one is processing the edges. We need to processing the edge for u comma v weight in self dot edges. Root u is equal to self dot find parent comma u. Next, the root v is equals to self dot find parent v. The parent v. If root of root u if root u is not equal to root v, mst dot append, we need to add into the minimum spanning tree u comma v comma weight weight. The next self dot union the parent comma rank comma root u comma root v. Iterates through the sorted edges and decided whether to include them in minimum spanning tree. The steps is used to determine the roots of the subsets for u and v. If the root u and root v are different, adding these edges will not form a cycle. Add the edges to the minimum spanning tree and union the subset of u and u. V. The last line self dot union is add the edges to the minimum spanning tree and union the subset of u and v. Next, return minimum spanning tree. The graph is equal to graph of 4. The graph that added 0, 1. 0 to 1 is weight 10, 0 to 2 weight is 6, 0 to 3 weight is 5, 1 to 3 weight is 15 and 2 to 3 weight is 4. Minimum spanning tree is equal to graph dot Kruskal. We need to call Kruskal minimum spanning tree function. The edges in the minimum spanning tree is equal to minimum. It shows we need to run this code. Kruskal's spanning tree function. The edges in the minimum spanning tree is, we need to run this code. It shows the edges in the minimum spanning tree is 2 to 3 is 4 and 0 to 3 is 5, 0 to 1 is 10. So the minimum weight, the weight of the minimum spanning tree is 4 plus 5 is 9, 9 plus 10 is 19. This is the minimum spanning tree. This is all about Kruskal's algorithm. If you like this video, please don't forget to subscribe, like and share and comment in this video.